Hello, everyone. Once again, uh, Pawel Gora. I'm a scientist from University of Warsaw and Gdańsk University of Technology. And today I would like to present you some of results of meta research, which I've done um, together with several other researchers, mostly within short-term scientific missions at Technical University of Munich. So the research concerns models, mostly simulation models and scenarios for autonomous connected transport. So first, I will present some most important information regarding this research, and hopefully at the end we'll have time for questions and discussions. So just to let you know, as I said, I collaboratively work on this topic with other people, for example, Professor Antonio, Christos Katrozakas, Farol Islam, Piotr Ostaszewski, Arek Drabicki, William Nayarian. Some of them are also members of our WISE action. And as I said, most of the presented meta research was conducted during two STSMs at Technical University of Munich in 2018 and 2019. So first, the motivation of this research. So as you probably know, it's commonly regarded that the era of driverless cars, autonomous vehicles, would change not only the performance of transport systems, but the overall picture of urban realm and of the world. So now we have an open challenge: how to assess the impact of connected autonomous vehicles or automated connected transport on transport, mobility, economy, social aspects, and some other domains. So one of the possible tools and approaches to do that, to assess this impact, is to develop accurate simulation and analytical models. But we have some challenges here because building good models requires having access to proper real-world data for calibration of the models. And in case of autonomous connected vehicles, we don't have such data yet, at least in a large scale. So we often have to rely on some assumptions and simplifications based on analysis of a given technology and surveys. And nowadays, most of the research on automated connected transport is done that way. But it's getting more and more difficult to make good assumptions and compare results of different studies because recently we can witness an exponential growth in number of studies and papers which are related to the topic of automated connected transport. So in this chart, you can see the number of papers related to this topic, which I identified during my first STSM in Munich in 2018. So this chart was not updated, but I expect that the number of papers is still growing exponentially. So the interest on this research on autonomous vehicles is still growing. So the problem is that these studies investigate multiple dimensions regarding, for example, different conditions, network conditions, input parameters, data sets, simulation tools which are used. So the problem is that there is a lack of general standards and for conducting such research, which implies that the studies may also produce divergent results or results which are not comparative and do not yield a uniform picture of certain aspects of connected transport. So, for instance, differences in simulation models, road network topologies, or assumptions on penetration rate of autonomous connected transport may lead to differences in output from simulation studies. So the goal of the work which we've done is to summarize main findings from the state-of-the-art research on possible impacts of connected autonomous vehicles, identify the most relevant data sets, tools, and criteria which could support the future scenario evaluation, and recommend how to organize research and studies related to autonomous connected transport. My methodology was based initially on analysis of Google Scholar database and profiles of some scientists, researchers working in the area of autonomous connected transport. And based on that, I identified the initial set of research papers, which was later extended based on analysis of the bibliographies, references, and abstract of this initial set of papers. So in total, we identify more than 200 papers, and that was state of the art in 2019. So based on initial review of some of those papers, we identified 57 dimensions, so parameters considered in autonomous connected transport related studies, which we can say define the evaluation scenarios. So those dimensions correspond to, for example, transport network, environment, demand and supply conditions, scale and time frame, different analytical tools, connectivity, and some other factors. So the corresponding number of dimensions was initially much larger, but we decided to cluster certain dimensions. So to do dimensionally reduction, we can say, which were relatively close semantically, and group them as a more generalized dimensions. So these 57 dimensions can be grouped into even more general dimensions. So basically, they form a hierarchy of concepts, or which can be interpreted as an ontology or a taxonomy. So we may have research metadata tools, data sets, inputs, and outputs. So this is how we can divide those 57 dimensions. So in case of research metadata, we may have, for example, type of affiliation or time of study. So those are factors which may also influence the possible results and conclusions. Among tools, we have 6 dimensions: simulation models, analytical models, surveys, driving simulators, real autonomous connected transport, so real vehicles from which we can collect data, and meta-analysis. So for example, the literature review similar to the one we've done in this research. In case of data sets, which represent real-world data, we have 5 dimensions: road network structure or supply, traffic data, demand, for example, information about demography, weather data, and some other data which don't occur in research works so often as other types. In case of inputs, we identify 22 dimensions. So, for example, geographical area, penetration rate, time horizon, duration, times of vehicles, whether there was a traffic control, what was the business model, whether there was a guidance or communication, what was the type of communication, what was the boarding time, for example, in case of autonomous services of autonomous vehicles, what was the supply type of road, for example. So yeah, these are examples of those 22 dimensions. Similarly, in case of outcomes from the studies, we also identified 22 dimensions. So, for example, scientists study safety, cost, value of time, demand, throughput, policy, and some other factors which you can see here. All right, so we built a database, we can say, of those more than 200 research papers, and this is represented currently as a Google spreadsheet file, which is available for everyone. So there's also a link, and I can also later share the slides. So in this Google file, we have a table with rows corresponding to specific papers and columns corresponding to those 57 dimensions. And initially, the idea was that we can just fill in this table, right? So we can try to review every paper and just add information about values of specific dimensions, specific values, right? So, but later we figure out that it's very time consuming, and it's almost impossible to do it just even on a group of 5 or 6 researchers, right? So as I said, the number of papers is growing exponentially, so it's not a job that can be done by a limited small group of researchers. But we started doing that, and Some of conclusions from this initial study was that there are many models, many tools, and different scenarios, and of course they are applied in many different areas. And traffic models may vary significantly, for example, as with regard to representation of dynamics of autonomous vehicles, input parameters, calibration models, calibration methods. So now the question was, among many existing models, which one is the best, right? Because there's a famous quotation that all models are wrong, but some are useful. And as I said initially, the problem is that there is a lack of real-world data to calibrate, validate models, and as a consequence, there's also lack of standardization for the research of autonomous connected transport. And therefore, as a consequence, all the works which we investigated so far differ substantially in their output observations and conclusions, which causes incomparable, not transferable, and sometimes also not repeatable study results. So, for example, there are totally different road networks used as an input. There are different models, different tools, different simulation tools used in experiments. There are different values of parameters, and it's really difficult to compare the results of different studies and to provide reliable conclusions from such researchers by just comparing results of different studies. So based on this initial review, we decided to give some recommendations or build a set of recommendations which may help organize the research on autonomous and connected transport in potentially in a bit better way. We'll see. So the first thing is that it may be good to build a repository of real-world data related to autonomous connected transport. For example, trajectories from real drives of autonomous vehicles, which can be later used for calibration, verification, validation of traffic models. And of course, if you want to build, calibrate, validate traffic models using such real-world data, it's also important to establish standards for doing that. And in case of conventional cars, conventional vehicles, we already have such standards, so probably it should be possible to do something similar in case of autonomous transport. Also, it may be good to just establish some standard use cases, scenarios, for example, standard road networks, to conduct experiments on exactly the same data sets, right? And then when we run experiments on the same road networks, then we can reliably compare different, for example, efficiency or safety of different algorithms and different traffic models. And also, even if we have some standard benchmark data sets, there might be also different models, analytical models, or different simulation models. So it may be good to develop a generic, open, and software agnostic benchmarking platform for the evaluation of alternative modeling approaches. And of course, it's important to conduct further meta-research on such traffic models and build a database of possible models and research works with information about their assumptions, inputs, outcomes, scope of applicability, in order to ensure comparability and reproducibility of results, as I said. So I already presented this Google spreadsheet. So initially, I thought that that might be a good idea to represent such data and this database in this Google spreadsheet. But I also mentioned that it's almost impossible for a single researcher or a small group of researchers to just fill in such database with all the required information, all the required knowledge. And the number of papers is growing exponentially, so it may become even more and more difficult in the future. So we need another approach which may be more scalable. And therefore, after thinking about it, I figure out that maybe a good approach would be to create a website with an interface. For example, it might be even a simple Google Forms, similar to the one presented, and at the bottom of the slide there's also a link where one can just fill in this survey. And by filling the survey, it might be possible to just provide all the required info. So basically, to provide values for all those dimensions which I presented before, and which are also available in this Google spreadsheet. So of course, not all information are necessary, and also not all information can be provided, because some dimensions are not related or not mentioned in a given research studies. But anyway, it seems to be a quite good and scalable approach, because, for example, the authors and readers of a single paper may easily add information about the article they have just prepared or read or reviewed. So for a person who is familiar with a given article, given research work, it should just take maybe up to a few minutes to do that. And it shouldn't be a very difficult and time-consuming job. But thanks to that, we can build a structured database with all important and required information, which might be a knowledge base for research on autonomous connected transport. And the important thing is that such database should be easily searchable to help in, for example, preparing a literature state-of-the-art review. Because nowadays, if we prepare a paper, a new research paper, then each time we have to do a comprehensive review of state-of-the-art existing literature. And sometimes it's difficult, sometimes it's time-consuming, and for sure, always we probably repeat work which has been already done by some other researchers. And also, thanks to such database, it might be much easier to find research gaps. For example, by analyzing such database, we can see that, for example, there were some research work concerning or studying the impact of penetration rate on efficiency, for example, but maybe only in urban areas or in urban areas, but without traffic control or without communication, right? So such research gaps can be easily found in such a database if only it's easily searchable. And of course, it might be much easier to compare outcomes from many different studies. Another recommendation is that all research works should be verifiable and reproducible. So I guess that probably that should be a universal general rule for all researchers working on in all research areas. So in case we use a software, a simulator, then source code or at least executable programs should be publicly available. All used data sets should be also available, or parameters used in experiments should be described in a paper or at least in supplementary materials, and all values used in experiments should be mentioned in the article. I think that the ideal scenario is a ready-to-use package, for example, a Docker container, which can be easily installed in order to reproduce the results of experiments, and potentially also change some parameters to run similar experiments with exactly the same tools on exactly the same data set, but maybe with some other values of parameters, or with another goal, for example, to study some other outputs. So, for example, in case of machine learning AI research, some of the best conferences have recently introduced the so-called reproducibility checklist. And every time, each time the authors submit a new paper to such a conference, then during the submission process, they have to answer several questions to verify that the work they have done is indeed reproducible. And perhaps maybe that is something that can be also used in case of transportation research or research on autonomous connected transport. Or maybe there are also some such reproducibility rules on some conferences. Maybe I'm just not aware of that. But for sure, that is something that that may help in just doing better research and ensure reproducibility of results. Okay, so what we can do further in this study, in this meta research, we can use the results to easily find the research gap which should be filled. So, and in fact, we've already started working on that together with other researchers. Right now, we are also investigating different microscopic traffic simulation models, including connected autonomous transport, and with a goal to build traffic models and algorithms which can optimize the efficiency or throughput, for example, of transport for different penetration rates. So this is the research that we've recently started. Also, perhaps we can predict the outputs of a given research based on the input, which might be a machine learning approach. So if we have such database, if we have a table of results of a research, then such database might be just a data set for some machine learning algorithms, which can potentially be trained on this data set to maybe predict the outcomes in case of studies where we still have some research gaps, right? So the hypothesis is that the results of studies, simulations, for example, may depend, of course, on complexity of tools, models, scenarios. And for complex models, it may be difficult to obtain good accuracy. But anyway, the results probably are not a random guess. So there might be some hidden patterns in such database, in such data set, from which we can try to infer some knowledge. For example, what might be the expected outcome of a research that we want to just conduct, and thanks to that we can organize better experiments. So this research and conclusions, and also more detailed review of state-of-the-art on microscopic traffic models have been already disseminated. So the first publication was at the Automated Vehicles Symposium in Orlando last year, and I presented a poster titled Traffic Simulation Models for Connected Autonomous Vehicles. And in this poster, I just also presented some most important microscopic traffic models which researchers use in different studies. So that was indeed based on this initial literature review. And later, at the Mobiltum conference at the Technical University of Munich, I presented a joint work with Kostas Antoniou and Arek Drabicki, titled Scenario Evaluation of Autonomous and Connected Transport, identifying datasets, tools, and criteria. And that was similar presentation to the one given now. And quite recently, our next article, but this time related more to just microscopic traffic simulations models for connected automated vehicles, was accepted for the International Conference on Ambient Systems, Network and Technologies. And this conference will be in April in Warsaw. So that will be the first article and scientific paper that we'll publish based on the literature review and the research that we started. Okay, so now I would like to also mention and thank once again about collaborators of this research, and just summarize that this research, meta research, was conducted during 2 STSMs. So this is more or less a summary of the work that I've done during those 2 STSMs. And if you are interested, then of course I invite you to join this research. I think that there are some interesting ideas on how to organize the research on automated connected transport a bit better, or to make it a bit more efficient. All right, so thank you for your attention, and if you have any questions, that I'm happy to answer and discuss this topic further.